How does a machine weighing 500 tons stay in the air? It begins with the battle against gravity.
The wing is not just a flat board. Its curved shape, known as an airfoil, is an engineering masterpiece.
As air hits the wing, it splits. The curved top forces air to travel faster than the bottom.
Faster air creates lower pressure, effectively sucking the wing upward into the sky with incredible force. At the same time, the wing deflects air downward. Newton's third law provides the final push for liftoff.
But without thrust, lift cannot exist. Engines provide the forward speed needed to activate the wings. Modern wingtips reduce drag by managing vortices, the spinning spirals of air left behind during flight.
When velocity reaches rotation speed, the wings finally take the load, and the wheels leave the Earth.
The cockpit is the brain of the aircraft, a complex interface where human intuition meets digital precision.
Pilots use three primary controls to maneuver: the ailerons for roll, the elevators for pitch, and the rudder for yaw.
By moving the yoke or side stick, pilots send electronic signals to hydraulic actuators that move massive control surfaces. In modern fly-by-wire systems, computers filter these inputs, preventing the aircraft from exceeding its structural or aerodynamic limits. Primary flight displays translate complex sensor data into clear, intuitive graphics, allowing pilots to fly through total darkness. The flight management system acts as a navigator, calculating the most efficient path across oceans and continents.
But the pilot remains the final authority, monitoring systems and making critical decisions that no computer can replicate.
As the destination nears, the crew prepares for the transition from the high-altitude cruise to the precise final approach. The final approach is a delicate ballet of speed and configuration, as the aircraft prepares to reunite with the Earth. Extending the flaps increases the wing's surface area, allowing the aircraft to fly at significantly slower speeds without stalling.
Gravity and hydraulics lower the massive landing gear, locking the heavy-duty struts into place for the impending impact. In the final seconds, pilots perform the flare, tilting the nose up to bleed speed for a smooth touchdown.
The wheels hit the pavement at 150 miles per hour as smoke erupts from the high-pressure tires. Engine cowlings slide back to reverse thrust, while carbon ceramic brakes convert massive kinetic energy into intense thermal heat.
Exiting the runway, the aircraft follows a complex labyrinth of blue and yellow lights toward the terminal gate.
With the engines silent and the passengers deplaned, the machine rests, ready to repeat the miracle of flight tomorrow.
Beyond the stable runways of land lies the most demanding environment in aviation, the aircraft carrier deck.
To launch a fighter, the catapult system must accelerate 40 tons to takeoff speed in just 2 seconds.
Steam or electromagnetic pulses provide the raw energy, hurling the aircraft into the sky with violent precision. Landing is even more difficult. It is a controlled crash onto a pitching, moving 4-acre target.
The tailhook must catch one of 4 steel arrestor wires, decelerating the jet instantly from terminal speed.
The tailhook must catch one of 4 steel arrestor wires, decelerating the jet instantly from terminal speed.
On the deck, a choreographed rainbow of crew members manages the chaos of high-tempo flight operations. At night, pilots rely on the meatball, a system of lights that guides them down an invisible path.
This is the edge of human and mechanical capability, where precision is the only thing preventing catastrophe.
While jumbo jets dominate the skyline, general aviation is where the soul of flight truly resides.
In a small cockpit, the connection to the machine is intimate, defined by analog dials and manual cables.
Small aircraft are light enough to feel the air's texture, reacting to every thermal and mountain breeze.
Learning to fly is a rite of passage, turning a student into a pilot through hours of discipline. Bush planes are the ultimate utility vehicles, capable of landing on rugged mountain ridges or remote riverbeds.
Aerobatics push these machines to their limits, performing rolls and loops that defy the horizon's steady line.
Float planes bridge the gap between water and sky, turning every lake into a runway for the adventurous. Every captain of a wide-body jet began here, in a small plane, chasing the horizon for the first time. Beneath the flight path lies an invisible infrastructure, a global grid of air highways managing thousands of aircraft daily.
Air traffic controllers are the silent guardians, orchestrating a complex 3D dance from darkened radar rooms across the world.
Every aircraft pulses with a transponder code, appearing on radar screens as data blocks moving across a digital map.
The sky is divided into sectors, where controllers hand off responsibility as planes transition from one region to another.
In busy hubs, aircraft are sequenced into stacks, circling in precise patterns until a slot on the runway opens.
Inside the tower, controllers use visual sight and ground radar to manage the delicate choreography of taxiing jets.
Communication is the lifeline, using a standardized vocabulary to ensure clarity and prevent fatal misunderstandings in the sky. This global network ensures that even in total darkness, no aircraft is ever truly alone or unmonitored in flight.